Hello, I'm Phil Townsend. I'm hosting this to give an intro into an ideas that we've been developing about the so-called BP Horizon oil spill. We've been working on this since the day after the spill. I've got engineering, economics, business background, and a lot of knowledge about the oil industry, so I've come up with some solutions which has been very difficult to market to the principal, to BP. That's what I'm doing today, is to describe what these ideas are and give you an idea about a way that this spill could have been solved and still can be. BP is spilling some oil into the ocean, and you've all heard a lot of excruciating details about how the oil got spilled and all the accident and who's people pointing blame, but basically this is a kind of a leak or a spill that could have happened and has happened before and will happen numerous times again. Somewhere in the world, people will be producing oil and gas underwater, usually under the oceans, and at increasing depths. And what happened in the BP spill was that they burned up a drilling rig and broke off some pipes, and they ended up with a situation where there's several different plumes of oil are proceeding from the bottom 5,000 feet below the surface, proceeding to the surface depending upon ocean currents. They are threatening all kinds of things all over the Gulf of Mexico, but what's basically been happening is oil and gas droplets have been forming out of these leaks and have been coming to the surface, and once they've gotten to the surface, it's a mess. This idea is derived from 2 or 3 generations of looking at this and trying to do some of the similar things to what BP is doing. If you try to capture these oil and gas droplets, what this plume looks like is this. It's a plume with oil droplets. This is the current here I'm drawing. It's a plume with oil droplets and gas droplets, and maybe some in the middle that are a little bit of oil and a little bit of gas. Maybe they're not quite as dense. These are denser. They have a specific gravity of 0.84 or 0.8-ish. And in the other parts of the plume, of this plume coming up to the surface, you have gas over here. Now the pollution is all coming out of the oil, and that's what we really care about, is how to capture this oil. So the idea is you can capture all the oil if you can get anywhere above this plume before it gets to the surface. You can capture the oil. When it gets to the surface, you've got surface turbulence in the ocean, and it's impossible then to collect all the oil. They try to disperse it with God knows what effect on the environment, but they cannot collect it well because they put out booms, and the ocean waves just interfere with that. When a storm comes, it gets much worse. But if you go down about 5 or 10 meters below the surface of the ocean, even during a hurricane, if you go down 5 meters, it's very calm with some kind of a more or less continuous current. If you don't like it there, go down 20 meters, and it's very, very calm. All you see is a current in one particular direction with a relatively small amount of turbulence. And so the plume at that point is very well behaved. Here's my idea. At that point, if you imagine a revival tent, large tent made out of canvas coated with plastic to protect it from almost hurricane winds, you can imagine assembling one of those tents below the ocean, below the surface. It's the right material to stand that. And if you put 2 or 3 or 4 of them together and stiffen them with pipes or with inflatable canvas tubes, inflate it with pumped seawater, well, you can end up imagining yourself with having several revival tents straddled across the place where this plume is going to be. Then your only problem is how to get the oil out. Well, that's easy, because that's what BP's been doing, is trying to capture the oil into a funnel of some sort and take it to the surface. But this funnel happens to be made out of tent material. You know what? From an engineering point of view, it doesn't matter. As long as it's strong enough, it doesn't matter that it's not rigid, because then you can pump it up to the surface, put it into the barge, and handle it the same way that their BP is handling a small fraction of the oil today. Now, this idea works whether this tent is 20 meters down below the surface. This is 1,600 meters here. If you get down to a certain level, the BP has run into a problem called methyl hydrates or methane hydrates. Methane and water form methane hydrates. They do so at high enough pressure and low enough temperature. There's some place, let's say it's 2,000 feet down, or 500 meters down in the ocean. Below that level, methane hydrates will form. Above that level, the temperature and the pressure will not form methane hydrates. So you lower this tent down to where it straddles the plume, recognizing that the oil is in the downstream or downcurrent part of the plume. Gas will come up fast. It will be on this side of the plume. Oil will come up much more slowly, and it will tend to be drawn further downstream. So this plume is likely to be segregated so that the pollution is in the downstream end. You make the tent big enough to straddle the whole plume if you can, but at the very least you catch the downstream tail of the plume. And you can go down as far as the methane hydrate zone with pipes or hoses, probably pipes, sucking the water up to our collection barges or ships where it's treated conventionally. Added little thrust is, even if you want to protect this against methane hydrates, you can take hot water. Once you've separated the water from the stream that you're pulling up, you take the hot water and pump it down into the tent, and in fact it'll prevent the formation of methane hydrates. So that's the idea. At first we thought, which we've now rejected, taking that down into the methane hydrate zone, we'd have the same problem that BP had. Our tent would plug up with methane hydrates. Now, this is a generic solution because there will be another leak under the ocean. There were leaks from pipelines during Ike, and the industry had to shut down those platforms until the pipelines could be completely repaired because they had no way to handle those leaks. This system would work for that. It will work in water that does not have a hydrate problem. If this were shallower, some of the onshore wells that exist various places in the world, it will work in the deepest well you can imagine because you don't collect the oil until it gets above the place where methyl hydrates are formed. We have an additional way that we've improved on that in recent days. We have decided that if it would be nice if we captured the plume down here at the bottom and brought it up to the tent without allowing it to spread out into the ocean. We probably can, as a second phase, we can use a tube with a conical bottom to collect the hydrates at the bottom and then bring it up toward the tent inside of a center tube and have an outer tube concentric with it and pump hot water down here, or actually use what we call a draft tube effect to suck warm water from up here into this cone, and then at the bottom we put that above any kind of leak, and the oil and water tend to come up the center pipe as the gas vapor bubbles vaporize out of the liquid. As we come up in lower and lower pressure, these gas bubbles get larger and larger, and that increases the speed with which the water is pushed up to the top. When it gets to the top of the tube, it separates from the tube into the tent, is collected in the tent, and conventionally is brought to the surface. So you put those two tools together, and we think it's part of a toolkit that allows people to respond to a leak under the ocean, whether it's a pipe or a vessel or a well. This idea has been communicated to BP. We have heard nothing. I think that's been a common problem, is that people have sent all kinds of ideas to BP. This one works. And it's sound science, sound physics, sound engineering, and it seems to me like it's very deployable, because this could be deployed quite quickly a lot of places in the world, since it doesn't consist of 300-ton pieces of equipment. And I thank you for your attention. If you are interested in this, you can communicate with me at ptownsend@ptai.com. You can also look at this and other parts of the same idea and other ideas we've been working on at ptownsendideas.com. Let me have your ideas. Thanks.